In this lesson, we're going to talk about similar solids. So we're talking about similar three-dimensional figures, like cones, prisms, pyramids, spheres, and that sort of thing. Okay, part of this lesson is really just a building block, so it's not going to make a whole lot of sense until we can put it together in the following lesson. So just kind of go along with it, but we're just trying to build a skill in this lesson. So first of all, similar solids, let's just define that to start with. So similar solids are solids that have exactly the same shape. So they're both cones, for instance, but not necessarily the same size, but they are going to be proportional to each other. Okay, so we're really just comparing all the parts again, just like what we would do if it was a two-dimensional figure. So for instance, here, when I look at these two cones, I'm going to have to compare a radius to a radius. So I want to compare 8 to 5. I want to compare the height to the height, so 15 to 12. And I want to compare slant height to slant height, so 17 to 13. So let's go ahead and take a look and see what those are. So 8 over 5 is 1.6. 15 over 12 is 1.25. So I could really stop. And 17 over 13 is 1.31. Okay, so they are not similar. So just like with two-dimensional figures, all of these numbers would have to be exactly the same in order to be similar. All right, so that's the big idea there. This is the building block part. Okay, if the ratio between two similar solids is A to B, so this is usually a one-dimensional length, then the areas are going to be in a ratio of A squared to B squared, and the volumes are going to be in a ratio of A cubed to B cubed. Okay, so this is where we're really going to spend a little bit of time. So first of all, one-dimensional measurements are going to be lengths, things that you can measure with a ruler. So it could be a radius. It could be an edge. A radius, an edge, a height, a slant height, a length, a width, anything that you can measure. Perimeter and circumference. Okay, those are all one-dimensional lengths. Two-dimensional lengths are going to be area. So it could just be plain old area. It could be surface area. It could be lateral area. We didn't really define lateral area when we did surface area, but what lateral area means, it's the surface area minus the base. So it's just the area of all the faces. That's really about it for area. Volume is, of course, volume. It also includes weight. Okay, volume and weight are typically the only thing that fit into that three-dimensional category that I can think of off the top of my head. So here's how it works. Let's say we have two spheres. No, let me do something else. We have two cones that have a radius that are in a ratio of 3 to 5. Okay, so even that means 3 inches to 5 inches. Whatever it is, they're in a ratio of 3 to 5. The surface area of those cones would be in a relationship of 3 squared to 5 squared, or 9 to 25. Okay, so their areas are in the ratio of 9 to 25. Volume then would be in a ratio of 3 cubed to 5 cubed, or 27 to 125. All right, so this skill right here, finding the ratios, is really what we're looking at. Okay, another example. What if I told you that the lateral areas of two shapes are in the ratio of, let's go, 9 to 36. Okay, keep in mind that is an A squared to B squared ratio. So I need to take it back to one dimension. So if I want to go from A squared to A, I would need to do the square root. So the square root of 9 is 3. The square root of 36 is 6. So really they're in a ratio of 3 to 6. You could also reduce that to 1 to 2. Then what I can do is I can find the ratio of the volumes. Okay, so you always have to go back to one dimension if you want to go higher. So if you have a ratio of 1 to 2, their volume is going to be a ratio of 1 cubed to 2 cubed, or 1 to 8. All right, so that's what we're going to practice next. Oh, I was wrong. We're going to do this first. Okay, so disco balls are spheres that are covered with reflective tiles. One ball has a diameter of 4 inches, another has a diameter of 20 inches. So it says find the scale factor. Scale factor of the two spheres. So that's just going to be 4 to 20, the small to the large, right? Now, a lot of times, especially when you're in one dimension, it's much easier to simplify it down that ratio. So this is really equivalent to 1 to 5. Okay, so this is my scale factor. Now it says find the ratio of the surface areas of the two spheres. So surface area is a two-dimensional measurement, so I need to square those. So I'm really looking at 1 squared to 5 squared, or 1 to 25. If I want to find the volume of the spheres, volume is three-dimensional. So I need to take the one-dimensional and I need to cube it. So 1 cubed to 5 cubed would be equivalent to 1 to 125. Now, what your homework is going to look like is like this. Okay, so I have a bigger table. I just made 2 examples here. I'm giving you a ratio of like a slant height, and I want you to tell me the ratio of the scale factor, the base area, the surface area, and the volume. Okay, so we're going to be going backwards and forwards. So slant height, that is one-dimensional. Okay, scale factor is one-dimensional. The base area, that's going to be two-dimensional. Surface area is going to be two-dimensional. Volume is three-dimensional. Okay, so my 1D ratios here, that's just 1 to 4. Two-dimensional means I need to square both of those. So that's going to be 1 to 16. Again, another two-dimensional, so that'd be 1 to 16. Three-dimensional means I need to cube the 1 to 4. So that's going to be 1 cubed is 1, 4 cubed is 64. Okay, next one, we need to start with volume. Okay, we know volume is three-dimensional. I need to work backwards to one-dimensional. So right now, this is an a cubed to a b cubed. So I need to take the cube root of both of those. So I need to take the cube root of 125, which is 5. The cube root of 216 is 6. Okay, that's our one-dimensional measurement, so that counts for slant height as well. I need to square those to get my two-dimensional measurements, my base area and my surface area. So it's going to be 25 to 36 for both of those. Okay, so you're going to be working on filling out a table like this, except it's going to be a drag and drop, because this is a critical skill for the next thing we're going to do.